So I'm going to show off some of my tooling. Hope you like it. This level generator procedurally builds a level from sections, but when we want a specific sequence of sections, we populate the sequential sections list. These sections will appear in order before the generator starts choosing random sections. This is super useful for testing. We set the number of checkpoints, their frequency, and the section to use as a checkpoint. We can optionally include some sections that will be guaranteed to spawn at some point using the necessary sections list. Health refills are a good use for this. Then we have the list of random sections we want the generator to choose from when creating the level. The generator auto follows the terrain height, never getting too high or intersecting the terrain with sections. Lastly, we need a level end section assigned. Nice. So the level generator deals with these sections. I've sorted a custom inspector to keep things as simple as possible for the user. All additional functionality outside of being compatible with the level generator is optional. If a section is to spawn coins, provide some transforms whose children are coins. These transforms are randomly set active when the section is initialized. For enemies, we provide a list of transforms that the enemy generator will assign a random enemy to. For general spawnables such as coins, health and NPCs, we provide a list of spawnable objects to randomly choose from and their locations. We can also check the include enemies ball to add the available enemies from the enemy generator. If we want the section to contain a surprise, we can set a list of spawnables to choose from, a location and a triggerer. Finally, we use the last two balls to set this section as a checkpoint or a level end. Excellent. For frictionless section design, I've created a bunch of moving platform prefabs with custom inspectors. We've got orbitals with radius, frequency, offset and clockwise settings. We've got linears with point A, B, frequency and offset settings. What we're calling waterfall platforms that instantly return to point A when they reach point B. Braking platforms that brake when they reach point B. As the architecture was in place, it seemed obvious to make our thwomp style enemies moving platforms as well, with settings for speed, wind up, recovery and cooldown. A previous tool, the proximity activator, came in useful here also. With the differing platforms having so much in common, I plan to put a slot for them in the section architecture, where we decide on a point A, point B and its frequency, and a platform type is chosen at random. Here are two more tools, one made for easily customizing time spikes with settings for extended and retracted time and a retracted position, and a swinging danger with frequency and offset settings. As for the DT particle system, the story goes, our mesh guy, WWDIMY, wanted to add particles to some things but was overwhelmed by the size of the Unity particle system. I thought I'd see if I could make a tool that only had the options required for this particular project. I wanted to use game objects as WWDIMY is familiar with them. The performance was limited, so I tried using compute shaders for the calculations, retrieving the data from the GPU via a buffer, and then setting the transform of each game object, only to learn that getting data back from the GPU is way slow. No worries, I'll use it when I want to interact with particles and I don't need many. I can still use it to demonstrate some tooling, voila. So I've built a friendly custom inspector for it. Triggered section expands if you check the ball to true. You can preview what the triggered system looks like with the button and alter the amount of duration. The amount has a range slider. I've used them on variables that could optionally do with some randomness between two values. There are always visible sliders for area, frequency, speed, lifetime and rotation. If you uncheck the random direction ball, you can choose the direction the particles initially spawn moving towards and set how much random variance to include, if any. The gravity section applies a force over the lifetime of the particle and is set to upwards by default to demonstrate that it doesn't need to be downwards. The drag slider is always visible and can be set to negative to instead provide acceleration. The scale section is always visible, with scale setting the size of the spawned objects, and the growth setting scales the particle over its lifetime, can also be used to shrink the object. Checking the grow then shrink ball scales the particle from lowest to highest value and back relative to the scale slide value. Yeah, nice.